Alright guys, here we go with 12.2 organizing data. I've had some technical difficulties, so this is take 3, which is always fun. If you notice from the introduction, I say that it's very hard to analyze and interpret raw data or make meaningful information observations about groups of numbers. We see this absolutely right now. If you're watching this in spring of 2020, you know that we got the pandemic going on. You see a lot of comparisons between the number of cases in the US and Italy. This is one of my favorite charts that I've seen on social media. Give it a second. There it goes. Now we're in focus. Where it compares the number of total cases in the US in blue to the number of total cases in Italy in red with an 11-day lag. Italy was 11 days ahead of us. Well, it looks like by the 19th and 20th of March, we are moving way past Italy, that our uptick is really high. What it doesn't take into account, this is just the number of cases. It's a raw data. It's not a good comparison. So many reasons why. First of all, we just started testing people recently to this data, so that attributes to that uptake. Also, Italy is a much smaller population. We have about 5 times as many people in the United States as in Italy, or a larger area. So this is, you would really want to look at a percentage of the population, not raw numbers. You can't compare them one-to-one. Italy's population is older than the United States. That makes them more at risk for this virus. Italy's population is more densely located. They live in apartments and in cities and have daily contact through public transportation a lot more than we do in the United States. We are a much more spread out and less dense population. So you cannot just compare those raw numbers. All right, let's move on to our organizing data notes and talk about a frequency distribution. A frequency distribution is just a list of observed values and their frequency, how often values show up. I've given you a data set based on the height of a group of male students. Just for reference, 5 foot tall is the same as 60 inches. These heights are given in inches. So 72 inches is 6 foot tall. If you think about how many data points we have, you count the number of heights listed, you see that we have 28 data points. So N, the number of data points, is 28 for this data set. You're told to make a frequency chart to organize the data. Now, a frequency chart is just super simple. You're going to list the heights. If you list them in order from least to greatest, it makes your life easier. And we're just going to do ticks to mark off the frequency for each height. The shortest height we have is 66 inches. The tallest person whose height is recorded is 75 inches. So we want to make spots for each of those heights. And then go through your list on your own, and each time you see a height represented, make a tick mark. For example, I've got 72, so I'm going to make a tick mark by 72. 70, 68. And once you're done with that, go ahead and count your tick marks so that you can more quickly compare them. And add up the totals you got just to double check and make sure all of your data points are represented. And then we're going to go through and we're going to answer some questions about this data. Be sure to pause the video if I get ahead of you. All right, tallest. Well, the tallest student represented in this data set is 75 inches tall. The shortest was 66 inches. The most common height is the one that shows up the most at 72 inches, with the second most common height at 71 inches. The least common height would be 69 inches because no one is that tall. We've got a total aid of 28 students represented. Which heights weren't listed? Well, that kind of depends on how you read that. 69 was listed, but there was nothing there. We didn't list any heights less than 66 inches or greater than 75 inches because we didn't have anyone in those ranges. Which heights show up multiple times? Well, if you look at your list, all the heights show up multiple times except 66, 69, and 74 inches. Overall, would you say these students are shorter, taller, or in between? Well, that depends on what you're comparing them to, right? Are you comparing them to middle school students, to high school students, to NBA players? What comparison are you making? Remember I said that 72 inches is about 6 feet tall. Most of my data is grouped right there, so I could say that most students are about 6 feet tall. But your frame of reference determines whether or not you consider that short, tall, or in between. Okay, let's look at the next page. A class is just a way to group data. When we're talking about statistics, a class is a way to group data. The class width is the number of integral values. Remember, an integer is a whole number, positive or negative, 1, 2, 3, 4, 5, -1, -2, etc. The number of integral values in the class. The midpoint, or the class mark, can be found by finding the average of the lower and the upper limits. So if I take the lower limit of the class and the upper limit of the class, add them together and divide by 2, I find the midpoint, or the class mark. My modal class is what we call the class with the greatest frequency, the highest frequency. The one that shows up the most. So if you look back at the chart that we had on the other page, at the frequency distribution, you see that it's not a class, it's just a value, but the mode would be 72 inches because it's the one that shows up the most. But that's not a class. Our next instruction says to start with that frequency distribution and make a grouped frequency distribution chart using that data, and we're going to divide that data up into 5 classes. Now, when we divide data into classes, each class needs to have the same width. If I look back at my heights, I see that I have 10 different heights. So I'm going to make my classes have a class width of 2. Excuse me. Class width is going to be equal to 2. So from our previous page, instead of height and frequency, now we're going to do class and frequency. My first height, my shortest height, was 66 inches. Since I'm going to have a class width of 2, this first class is going to contain all students who have a height of 66 or 67, not 77, 66 or 67 inches tall. Then the next class would be 68, 69, 70, 71, 72, 73, sorry guys, 74, 75. Every class has the same width. I chose a width of 2 so that I would have 5 classes of equal widths. All right, look back on the last page and look at the frequency for each of the individual heights. If I add together the frequency for the height 66 and 67 inches, I get 4 total students represented in that class. If I add the heights for 68 to 69 inches, there are only 2 students that fall in that class. 70 and 71 contains 8 students based on the frequencies from the last page. flip back over there just to show you what we're doing. 1 plus 3 is 4, 2 plus 0, 2 plus 6, and then I'm going to be adding together those remaining rows into my classes width 2. Okay, so now let's answer some questions about these. The modal class, remember the modal class is the one with the highest frequency, the one that represents the most students in this case. Well, my modal class is going to be 72 to 73 inches because it has the highest frequency. Identify its midpoint. Well, the midpoint of the modal class is only 2 inches wide, so it's going to be halfway in between. Well, halfway between 72 and 73 is 72 and a half. But remember, I showed you how to calculate it if it's not that simple. You add the 2 limits and you divide by 2. That's the average of those limits, lower limit, upper limit. So to find the midpoint or the class mark, I add the 2 values for the upper and lower limits, divide by 2 to find the average of those 2. Overall, are the students shorter, taller, or in between? Well, we're back to that same argument of what we mean by shorter, taller, or in between. If they're just comparing them to each other, they're a little taller because when I put my heights into 5 classes, I can see that it's a little bit heavier down at this end. So let's just say we're going to compare them to themselves. We would say that they are a little on the taller end, because that's where we start seeing our data group up. Okay, a bar graph. A bar graph is a graph that measures frequency, just like that frequency distribution that we did, and dividing our frequency distribution into classes. The bar graph measures frequency. It's used for discrete values. Discrete. A discrete value is something that is countable. A discrete value is something that is countable. If we were in the classroom and I counted the people in the room, I would count them 1, 2, 3, 4, 5, 6, 7. There's always going to be a whole number of people. There's never going to be 2.3 people in the room. It's not continuous. It's discrete. With a bar graph, the bars do not touch. That's important when I'm constructing a bar graph. The bars do not touch. Now we're told to make a bar graph representing the class results of favorite type of fruit. Okay, we don't have a class, but I have the results of the last class that I asked this question to. I asked them how many people like citrus fruits best, and 1 person chose that. 11 people chose that they liked berries best. 3 people said they liked apples best. 3 people said that they liked bananas best, and no one picked that other category. So those were the results of my class poll the last time I asked this. So let's go ahead and use those results to make our bar graph. The first thing we need to know is how many people, how many data points are represented. Well, let's add up our answers. We had 11, 12, 15, 18 data points. The highest number, the highest frequency was berries, so that we know that we don't need to have a graph that goes up any more than 11 high. Let's go ahead and set up our axes for this graph. Sorry, my pen was not wanting to cooperate. So there's my x-axis going across horizontally and my y-axis going up vertically. If I start to number those axes, I need to think about numbering them in ways that make sense. I'm not going to number the x-axis. I'm going to list the types of fruits I have. I have citrus. I have berries. I have apples. Let's see, if we do, yeah, I'm going to do it this way. I have apple was a favorite, banana, and other. Now I want my width of my bars to be the same so that the area represented is consistent. And then I need to number up this left hand, this upper y-axis. I think we're going to count by 2. So this would be 0, 2, 4, 5, 6, 8, 10, 12, 14 if I wanted to go to 14, but I don't need to because I already know that my highest frequency is 11. So citrus, I had one person vote for citrus. I'm going to make my citrus bar go up to what 1 would be. There's my citrus bar. And then berries, I had 11 vote for berry. So that's going to be that high. I'm going to try to keep a consistent width. There is the frequency bar that represents the people who voted berries as their favorite fruit. And then I've got apples. Only 3 people voted that they liked apples best. I've got kind of stretched out here on my x-axis. I didn't do a very good job of writing them in and judging where I wanted to put my bars, but that's okay. So that's apple. And then I've got banana. Bananas, 3 people voted for bananas. And no one voted for other. So there's just not a bar that represents other. It's at 0. It doesn't go up at all. I didn't do a great job of my x-axis. I'm not going to redo it. There it is. That's a bar graph. Bars don't touch. Represents frequencies. Histogram also measures frequencies, but instead of discrete values, a histogram is used for continuous values. Continuous values are things like measurements, things that can be measured. I can measure how tall you are. That is a continuous scale. People aren't either 5 feet or 6 feet tall. They're not even either 5'8" or 5'9". They could be 5'9 1/3 or 5'3.5" inches tall, or I could get even more specific if I wanted to. Those are continuous values. So if I'm going to do a histogram, the bars are going to touch. Now, I'm going to do a histogram based on the frequencies that we did with the heights from that first data set. The histogram is going to use the 5 grouped classes. So you can look back at your classes on the last page to help you set up your histogram. Our bars are going to touch, so that makes my x-axis a little easier. My first class is 66, 67 inches, and then I have 68, 69, 70, 71, 72, 73, and 74, 75 as my 5 classes. Frequencies, let's go ahead and count by 2s again. So 0, 2, 4, 6, 8, 10, 12. We'll go ahead and number up to 14, but we don't need to go quite that high. Okay, looking back on my last page, the frequency for this first class was 4. So that's how high that bar needs to go. And remember, the bars touch here. For the second class, 68, 69, my frequency is 2. For 70 to 71, it was 8. Creating our histogram. For 72, 73, it was 11. And then for 74, 75, we had 3. Okay, so there is my histogram. Okay, let's look at the next page. What are the differences between a histogram and a bar graph, it asks us. We've talked about these differences, so let's go ahead and put them down on paper. A histogram works with discrete variables, countable variables. Oh, I got this backwards already. I'm sorry. Let's start over and go up. Bar graph. Bar graph, because that's what we did first. A bar graph starts with discrete variables, which means they are countable, not continuous, so the bars don't touch. For histogram, however, I'm working with continuous variables, measurements, and because it's continuous, the bars do touch. All right, frequency polygon. Another way your book introduces graphing as using a frequency polygon, which is basically just a line graph with scales that are just like the histogram. We're told to construct a frequency polygon of the height data using the histogram we created as the basis. So here's what we're going to do to construct our frequency polygon. First, it says we're going to use our histogram. So let's go ahead and structure our graph the same way we structured our histogram on the last page. Write in your class limits and number your frequency y-axis. Okay, to make this frequency polygon, you are going to start and end your line at 0. So we're going to start our line down here at 0. We're going to end down here at 0. And then you are going to connect the midpoint of each class. Connect the midpoint of each class. So let's think about the midpoint of each class. Okay, let's think about the midpoint of each class. Let's go back to our frequency, our histogram, and let's mark those midpoints. Our midpoints would be the center of our bars. There's our midpoints, the center of each bar. So I've got 4, 2, 8, 11, and 3. Okay, let's come back and go where the centers of our bars would be at 4, 2, 8, 11, and 3. And those are the points I'm going to connect with a straight line. Start and end at 0. So I start at 0, I go up to 4, down to 2, up to 8, up to 11, down to 3, and then I want to end back at 0. That's what a frequency polygon looks like. Okay, stem and leaf plot on the next page. A stem and leaf plot is best for small data sets. If you get too big a data set, the stem and leaf plot gets really cumbersome and it's difficult to read. It's really easy to turn into a histogram. I'm going to show you how to do that. A group of test grades are shown below. Make a stem and leaf plot for the data and answer the following questions. Now, a stem and leaf plot gives you more information than a histogram. With a histogram, we know how many fall in that class, but we don't know the individual values. With a stem and leaf plot, we know not just how many, we don't just know the frequency, we also know exactly what the values were. First things first, count how many grades you are given. When we count up our data points, we discover that we've been given 27 grades. So we will have 27 grades represented on our stem and leaf plot. Now look at your grades, see what the lowest grade is and what the highest grade is. And we are going to use the 1 digits as our leaves and the tens digits as our stem. So the stem is going to be the tens digit and the leaf is going to be the ones digit. All right, so what's my lowest grade? Well, my lowest grade looks like a 47. My highest grade's 100. Oh, no, 102. My highest grade's 102. So I need stems from the 40s to the hundreds. My stems are going to go over here on the left. So I'm going to divide this off to show that my stems are going to be over here on the left. We're going to go from least to greatest. So we're going to go from top to bottom, least to greatest. And we're just going to start here. I'm going to say, okay, 4s, 40s, 50s, 60s, 70s, 80s, 90s, and hundreds would be a 10 tens. 4 tens, 5 tens, 6 tens, 7 in the tens, 8 tens, 9 tens, 10 tens represent hundreds. All right, now we're not just going to count the grades. We're going to say exactly what they are. 47 is my only grade that falls in the 40s range. So I put the leaf here. Let's do leaves in a different color. I'm going to put the leaf there as a 7. So that grade is 47, and that's my only grade in the 40s stem. What about 50s? Well, I've got two grades that fall in the 50s. I've got a 57 and a 58. I put them in order from least to greatest. So I put my leaves down as a 7 and 8 to represent 57 and 58. 57, 58, stem to leaf, stem to leaf. Notice how I'm lining them up in columns so it shows me how many leaves there are in a nice organized way. All right, 60s. What grades fall in my 60s leaf? 63's there. 62 and 67, those four grades fall in the 60s range. I need to represent all four with their leaves. My leaves are going to be 2, 3, 3, 7 in order from least to greatest. Okay, you guys finish this stem and leaf plot. Pause the video, finish it out, and then come back and look to see if yours matches mine. Okay, so there's my stem and leaf plot. You can see that there were more 90s grades than anything else because that is a longer value. And I know exactly what my grades are. My grades were 91, 91, 93, 93, 96, 96, 96. So I know how many 90s there are and exactly what the grades were. All right, let's answer these questions down at the bottom. First, we're asked how many Fs were there? Well, we need to just determine what represents an F. If we decide that Fs are my 40s and 50s, anything less than a 60, then we have 3 Fs. How many A's are there? Generally, anything 90 and above is considered an A, so we count our 9 and 10 leaves, and we see we have 10 A's. What's the most common grade? Well, the most common individual grade is a 96 because I have 3 96s. The most common group of grades are my 90s. What's your overall impression of the class's performance? Overall, they did well on the test. Only 3 out of the 27 students failed the test, and I had 10 A's, so that's excellent. Almost more than a third of them made A's on the test, so they did well. Now, remember I said that I could show you how to turn this into a histogram? Take your stem and leaf plot and turn it on its side. If I were to build bars around this, I have a histogram. So a stem and leaf plot is like a histogram, but with more detail. Okay, let's talk about a circle graph. A circle graph doesn't show frequency. A circle graph shows parts of a whole or percentages. And you really shouldn't have more than 7 sectors if you want to be able to easily read your circle graphs. You're going to find circle graphs with a whole bunch of sectors and a lot of different pieces of the pie, different divisions in there. They're really hard to read. Okay, so read our situation here. We're looking at people who were at the circus, and they were asked what their favorite performance was. Well, you can quickly see that more people like the tigers than anything else. A few people didn't have a good answer. Or maybe they did have a good answer, they just picked something that not many other people picked. Maybe they said the popcorn was their favorite. That's not a performance. Notice that clowns were not on the top of the list. All right, how many people total were asked? Well, N is 800. That's given to us right at the beginning. 800 people were asked. How many people said that they liked tigers best? Well, 38% of those 800 people questioned said they liked tigers best. So I need to know, what is 38% of 800? Remember that to do of, that means to multiply. So I would take 0.38 times 800. And that tells me that 304 people out of 800 people said they liked tigers the best at the circus. Go ahead and do that same process for all of these to find out how many people picked each of these different acts as their favorite. The entire circle represents all 800 people, so when you're done, your values should add up to 800.